Hello students, in this session I am going to explain the next topic which is called as scheduling criteria. Before going for scheduling criteria, we have discussed the concept we have discussed. I am going to just brief it out. For example, we have discussed about what is ready queue. So ready queue is nothing but a queue which is used to store the process. Okay, process 1, process 2, process 3 and process 4. So ready queue is going to store the process, and from ready queue the CPU is going to select any one process for execution. Okay, so this is done by dispatcher. Okay, or it is also called as short-term scheduler. So short-term scheduler is going to select one process from the ready queue and it is going to allocate CPU for execution. So this we have discussed. Under this we will come across the concepts like what is waiting. Waiting is when the CPU or the processor needs any input output, it needs to read input or it needs to perform for some output function, then it will go to waiting state, where it will be waiting for what? It will be waiting for input or output device. Okay, it will be waiting for input or output devices. Okay, now after this there is one more way of waiting is when there is any interrupt occurs. Okay, so when there is any interrupt, so in that case also the process will go across waiting state. Okay, now this we know, these are the basics regarding what is ready queue, what is dispatcher and how it is going to execute, and this process of selecting any one process for execution will consider as scheduling, or when we switch from one process to other process we will consider it as scheduling. Okay, now under this we will come across two things called as arrival time as well as waiting time. So what is arrival time is? Arrival time is say for example, if I give some clock, say every process or every function or execution in the that is done by a processor will be counted in terms of milliseconds. That is, I am going to use ms, which will be representing milliseconds. Okay, so that is every process that is executed on your executed by your CPU will execute within some milliseconds. Okay, so we'll be representing milliseconds in terms of time. So if I start a process, so that process will start at 0 milliseconds. So once a computer has started, so it has loaded a process, so that is nothing but at some 0th millisecond process 1 has entered. After few minutes, maybe second process or third process has started, so I'll consider it as one more process which is at second that is say 10 milliseconds, we have one more process that has to be executed. So in ready queue, as you start a process, so if I start a process at 0th milliseconds, that will be loaded into ready queue. At 10 milliseconds there is one more process called as P2. So at 12 milliseconds I'll have one more process called as P3. Like that you can have any number of process that will be loaded onto the ready queue for execution. So what is arrival time is? Arrival time represents when the process is loaded or when the process is entered into the ready queue. When the process has entered into the ready queue, that state will consider it as arrival time. So which is at which millisecond the process has loaded onto the ready queue, that we are going to represent it as arrival time. Okay, so you can also consider a simple example when you have when you see this train timetable or something like that. Okay, so online train timetable, when you see, you will come across arrival time and departure time, all those things. Okay, arrival time is when the train enters to the station, departure time is when the train leaves the station. Similarly, when a process enters into the ready queue, that time will consider it as arrival time. Okay, now waiting time. What is waiting time is? We know CPU is required for executing the process. CPU is required for executing the process. when a process enters into the ready queue, so if the CPU is executing other process, it cannot select this process for execution. So it will be in the ready queue. Okay. So it will be representing the form of milliseconds. That is, for how much time the process is in ready queue. Ready queue, that is nothing but waiting time will represent for how much time the process is waiting for execution. That will be represented by waiting time. Okay. So these are the basic things or terms that you should understand before going for the problems based on scheduling criteria. Okay. So these are clear. So we have discussed about what is ready queue and what is how the CPU is going to select for execution, and after that we have discussed what is arrival time and what is waiting time. So next, coming for CPU scheduling criteria, in that first we are going to discuss what is CPU utilization. CPU utilization is nothing but, for example, in any situation the CPU should not be idle. So our main aim is we need to avoid the idle state of CPU. So idle state of CPU can be avoided only when you give one process after the other process for execution. When you allot more than one process for execution, then CPU will not be idle. So what is CPU utilization is, or our main aim of scheduling criteria is to make the maximum utilization of CPU. So CPU will be used for the maximum extent and we should avoid idle state of the CPU. Okay, so it should not be free. We should give some process for execution to the CPU. Okay, so that is CPU utilization. Next, coming for throughput. What is throughput is, say for example, I'll take 200 milliseconds. In 200 milliseconds, how many processes executed? Okay, how many processes are completed its execution? That count or that measure will consider as throughput. Throughput is the number of process executed per time. So you can write simply, so number of process per time. So this will be representing throughput. Okay. Next, what is turnaround time? So turnaround time is from the time of arrival. So say for example, time of completion. So or you can also consider it as time of submission. Okay, minus arrival time. Okay, so this will be representing turnaround time. What is turnaround time in the sense? For example, if a process has entered at 10 milliseconds, P1 has entered at some time called as 10 milliseconds and it has completed its execution at 20 milliseconds. Now, how much time it has taken for completion of the execution? 10 milliseconds. So, the process 1 has arrived at 10 milliseconds. It has completed its execution at 20 milliseconds. So, the amount of time it has taken is 10 milliseconds. So, the turnaround time will represent the amount of time taken by the processor to complete its execution. It will also include waiting time. Okay. If you have any waiting time, if the processor is waiting for any, if the process is waiting for any input, output or any other function, that will also be included in turnaround time. So turnaround time is just like how much time it has taken for completing its execution, which is nothing but turnaround time. Okay. Next is waiting time. I told you what is waiting time. Waiting time is from the time of arrival, when the process has arrived and when it has been selected for execution, or the total amount of time that process spends in waiting state, that is nothing but your waiting time. And coming for response time. What is response time is when you have submitted your process. Say for example, if the process arrives at 10 milliseconds and the CPU selects this process for execution at 15 milliseconds. Okay, so that is, this process will be waiting for how many milliseconds? 5 milliseconds it will be idle. It will be in the ready queue. So that is for the first time, how much time the process is in the ready queue. before the first selection, how much of milliseconds the process is in ready queue, that will be considered as response time. Okay, so this is about what are the basic things that you need to understand regarding scheduling criteria. I will discuss once again. Say, listen, we have CPU utilization, which is nothing but how much time or we need to make. Say for example, to the maximum extent of time, the CPU should not be idle. So CPU should be used for the maximum extent, which is nothing but CPU utilization. What is throughput is for a given time, if I consider 20 milliseconds, how many process or number of processes that has completed its execution, that is considered as throughput. Next, coming for turnaround time. Turnaround time is, it is like total amount of time. So that is the time of completion minus the time of arrival. So when the process has arrived and when the process has completed its execution, from the time of arrival to the time of completion, how many milliseconds it has taken, which is like turnaround time, which may also include waiting time also. Okay, and waiting time is the time the process has spent in ready queue. Okay, so the process spent in ready queue, or the time which is spent by the processor in ready queue or in waiting state, which is nothing but waiting time. And coming for response time. Response time is that is, if the process has arrived at some milliseconds, so and 0 milliseconds, it has been selected by the CPU at 5 milliseconds. Okay, for the first time, then the response time is what? Then the response time is 5 milliseconds. It is just like when you go to any like say any queue, or you're standing in a queue, you're going to buy a ticket. In that sense, you'll be waiting for half an hour. So the first time you gave the response was at 30 minutes. That is the response time. Similarly, when the process arrives and by the time the CPU selects it for the first time, it will be spending 5 milliseconds. So that is the response time of the CPU. Okay, so these are the basic things that you know. If you understand these things, then I will continue with the problems. Okay, so next I'll continue the problems. We have different types of problems, where I'll just mention 3 types and I'll explain what it is, and later we'll see how the problem we are going to execute. We are going to do the problem. Okay, now, so we have different types of scheduling criteria. So under that, various methods. First we'll have as first in, first out. We have shortest job first. So shortest job first, and you have round robin. Okay, so these are the things that we have, and we have different types. So we'll see what is the meaning of this, and what is, we have already discussed the things like what is pre-emitter and what is non-pre-emitter. Okay, so if any process, what is pre-emitter? What is pre-emitter is, these are the process, if the CPU executing, say for example I have process 1, and this process 1 is executed by CPU, and the scheduler cannot remove this, or can remove this program or this process from execution whenever they want, then those type of process will consider as pre-emitter. So any process that can be removed by the scheduler from execution is called as pre-emitter. Non-pre-emitter is, these are the process, once it has started execution, it cannot be removed from the CPU until it has terminated, which are called as non-pre-emitter. Okay, so that is, the process or the scheduler cannot remove the process from execution until it has completed, or if it goes to IO. If these two states are not there, that process cannot be removed from CPU, which are like non-preemptive. What is preemptive is these are the process that can be removed by the scheduler whenever they need. Okay, so we know this, what is preemptive and what is non-preemptive process. Okay, next we'll come across the types of scheduling criteria or problems that we have is, first one is called as first in first out. First in first out is, as you know, as it represents, if you have the queue, we have the process 1, process 2 and process 3. Okay, if process 1 is coming at, or it has started at 0 milliseconds, and process 2 has started at 12 milliseconds, and process 3 has started at some 17 milliseconds. Okay, and say it will end at say 20. Now this will represent this process has arrived at 0 and it is going to be executed first. So this is the first process to come, so this will be executed first. Then we are going to execute process 2 and then we are going to execute process 3. Okay, so meanwhile we have two things we need to learn. What is arrival time and what is burst time. Okay, so what is arrival time and what is burst time? Arrival time is when the process has entered the ready queue. When the process has entered the ready queue, that is nothing but your arrival time. What is burst time is how many milliseconds the process needs for execution. That is, this is execution time. Okay, so for taking input I need 2 milliseconds, for printing input I need 3 milliseconds or something like that. That type of time, how much time the process needs to complete its execution, which is represented by burst time. So if I represent some process like this, so I'll write process, so I'll write P1, P2 and P3. Okay, so I have three process. Arrival time is process 1 has arrived at 0, process 2 has arrived at 2 milliseconds, process 3 has arrived at 4 milliseconds. And burst time is this process will take say 5 milliseconds for execution, this process will take 3 milliseconds for execution, and this process will take some 4 milliseconds for execution. Okay, now if I want to draw how this process will be stored in the ready queue, first if I have the queue like this, initially it will be empty. At 0th milliseconds, which process I have? P1. So 0 milliseconds I will have the first process, which is P1. After that P2 has entered at which milliseconds? Second milliseconds. But P1 is completing, taking how many milliseconds? 5 milliseconds. So till 5 milliseconds P2 will not be started. In which method? In first come first serve method. And again P2 will enter at 2 milliseconds, in the sense it will be entered at 2 milliseconds itself. By the time here we'll get 2 milliseconds, we have one more process P2, but I cannot execute this. Okay, so that we'll discuss in first out. Okay, I'm going to explain in detail again. So I'm just explaining how to draw this by using these two values. Okay, now this, that is nothing but when it is 2 milliseconds, when P1 is under execution, P2 has arrived, but I cannot change it because we are using first in first out. I have for P1 first P1 should be completed. Next P2 has arrived and it is taking how many milliseconds? 3 milliseconds. So after 5 milliseconds I am going to select P2. So I am going to select P2, which will take 3 milliseconds, in the sense after 5 milliseconds it is going to consume 3 more milliseconds, which is nothing but 8 milliseconds will be for P2. Next process we have is P3. So we have P3 process which has arrived at 4th millisecond, but it needs how many milliseconds for completion? 4 milliseconds. So that is 8 plus 4 will be 12. So in 12 milliseconds we are completing process 1, process 2 as well as process 3 in the order of first in first out. So first process 1, next process 2, next process 3 has completed its execution. For this we will be calculating all the things like what is response time, what is waiting time, what is turnaround time, all these things we are going to calculate, and what are the throughput, all those things we need to calculate for this problem. Okay, so this is about how you assign a process and how the process will be executed in your CPU with a sample example of first in, first out. Okay, so I'll continue here itself. In this video itself, I'll be continuing with the next topic, which is first in, first out. Okay.